Welcome to the video podcast on naming inorganic compounds. We are not going to be looking at naming acids in this particular podcast, so that's something, if you're interested in naming acids, stay tuned for the podcast that will deal specifically with this. But we're going to deal with inorganic compounds containing what we will label as type 1 metals, type 2 metals, binary molecular compounds, which are compounds that do not contain a metal at all, and then compounds that contain polyatomic ions. So that will be our focus today. We're going to start first with binary molecular compounds. These are compounds that contain two different non-metallic elements. Now, binary means there are just two elements in it. There can be different ratios of these two elements, but these are non-metallic elements that share covalent bonds, meaning that they share electrons rather than transferring them from one element to the other. And both of these elements will be found in the upper right-hand part of the periodic table. Here are the elements that we're concerned with when we're looking at naming binary molecular compounds. From group 14 or 4A, the two elements are carbon and silicon. From 5A or 15, nitrogen and phosphorus. From group 6A or 16, oxygen, sulfur, and selenium. And then from 7A or 17, which is also known as the halogens, we have fluorine, chlorine, bromine, and iodine. And one of the things that you'll notice is we're not talking about hydrogen right now, and the reason for that is when we have hydrogen involved in a binary compound with another nonmetal, we're generally going to name that as an acid. So right now we're just concerned with these elements. We'll have a whole different podcast that will deal with hydrogen, so be patient as you look for this. But these elements are in the upper right-hand portion of your periodic table, and that's where you find them. So when you have a compound where the formula contains just two elements, and these elements are all from the upper right-hand side, we're going to name these as binary molecular compounds, not ionic compounds. Binary molecular compounds are named with prefixes. This really makes them the simplest of all inorganic compounds to name, and why we're looking at them first. But the following prefixes need to be memorized. If there's just one of the element, we'll use mono, 2 is di, 3 is tri, 4 is tetra, 5 is penta, 6 is hexa, 7 is hepta, 8 is octa, 9 is nona, and 10 is deca. Now you can go beyond 10. For instance, 11 would be undeca, 12 would be dodeca, but generally when we're looking at binary molecular compounds, it's rare that you would go over 10. Couple of very basic rules when we name binary molecular compounds. The first is that when we look at the first element that is written in the formula, if there is simply one of that element, meaning it does not have a subscript of 2 or greater, then we do not have to use a prefix with it. We just name the element as it's named. All the second elements require a prefix, whether there is 1 or 2 or 3 or 4 or whatever. It has to have a prefix. The second element is also given an IDE ending. So again, the first element, if there's more than one of that element, put a prefix with it. If there's only one, do not put a prefix with it. The second element must have a prefix, and the second element will always have an IDE ending. Here are some examples. Here we have a formula of PF3. This is phosphorus trifluoride. Because there's just one phosphorus, it does not require a prefix. The second element there are 3 of. Whether there was 1 or a dozen, it would need a prefix for the second. So phosphorus tri, because there are 3 fluorides, phosphorus trifluoride. And again, remember the ID ending at the end. H2O, normally we'll just name this water, but if you were to name this using prefixes, it would be dihydrogen monoxide. P2O5 is diphosphorus pentoxide. Notice here that because we have more than one phosphorus, it requires a prefix. Okay. Then P4O10, we have tetraphosphorus decoxide. Notice with the decoxide, when oxide is that second element, for the prefix with it, we drop that end A off of the deca and just put decoxide there. N2O is dinitrogen monoxide, and NO2 is nitrogen dioxide. Your turn. Let's try an example problem here. I want you to name the following compounds given the formula. So you'll want to pause the podcast at this point and write down the compound names and then come back and we'll see how you did. Well, here are the answers. Check yourself. For CCl4 we have carbon tetrachloride. No prefix for the carbon because there's just one of them. Must have a tetra prefix on the chloride to show that we have 4 of those. CO2 is carbon dioxide, CO is carbon monoxide, OF2 is oxygen difluoride, N2O5 is dinitrogen pentoxide, and finally NO is nitrogen monoxide. Very important to remember, the first element, if there's just one, does not require a prefix. The second element requires a prefix whether there are 1 or a dozen. So if you remember that, you should be in good shape. This next example problem has you writing the formula for the following compounds when you're given their name. So again, when you do not see a prefix for that first element, there's just one of that element. And when there's just one of an element in a formula, you do not have to write the subscript 1. The second element, remember that the prefix will tell you what the subscript should be. So again, pause the podcast at this point, take a look, and then come back and we'll see how your answers compare to mine. Good luck. Let's check your answers, see how you did. Silicon tetrabromide, SiBr4, phosphorus trichloride, PCl3, sulfur dioxide, SO2, carbon diselenide, CSE2, dinitrogen tetroxide, N2O4, and sulfur dichloride is SCl2. Hopefully you did well on those. If not, you may want to go back and try them again. This is the end of part 1 of the video podcast series having to do with naming inorganic compounds. I want to leave you with a quote from C.S. Lewis. An explanation of cause is not a justification of reason. I wish you well. Stay tuned for part 2.